Welcome to my space. It's your favorite science tutor, Okoro Sapenes. And in today's video, we shall be looking at a continuation of the topic, linear inequalities. And for today, we shall be solving problems on two variables. The last time we met, we solved problems on one variable, how to draw inequality graphs on one variable. So for today, we shall be taking a series of examples on two variables. So for two variable inequalities, let's look at some examples. Let's assume we have, we're told to solve y is less than 4x plus 2. Now, an example like this is a two-variable linear inequality. How? We have variable y and variable x. So x and y represents two variables. And how do we solve such an inequality? Solution. In solving two variable linear inequalities, we assume equality. Equality in the sense that we assume that we are working with equality. That is, y is equal to 4x plus 2. So we start by saying when x equals 0. So when x is 0 here, it means automatically this parameter is 0, so y is equal to 2. So y gives us 2. We also do the same for y. When y equals 0, x will be, when y is 0 here, we have 0. 0 is equal to 4x plus 2. So when we move 4x to the left hand side, we have minus 4x equals 2. So dividing 2 by negative 4 minus 4 on both sides, we are going to get x to be equal to minus 1 over 2, which means minus 0.5. So when x equals 0, y equals 2. When y equals 0, x equals minus 0.5. So inversely, we have our values to be, in the first case, x, y will be 0, 2, and y, x in this case here, we have minus 0.5, and 0. So we are going to use these two coordinates to plot an inequality graph, and then we decide the boundary where the solution is real. So how do we go about that? We have our graph. This is our origin. This is 0. We have 1, 2. On this side, we have minus 1, minus 2. Moving upwards, we have 1, 2. Moving downwards, we have minus 1 and minus 2. Now, the first case says when x equals 0, y is 2. X 0, y 2. X 0, y 2. Remember, this is the y-axis, this is the x-axis. So when x is 0, y is 2. So I'm going to make a mark up here. When x is minus 0.5, y is 0. When x is minus 0.5, on the x-axis, we have minus 1, so minus 0.5 is on this side. Y is on the 0 line. So minus 0.5 is on this line. So these are my points. You can see the 2 points. So I'm going to attach a straight line through it. But first of all, take note, we have less than. In as much as we assume equality, we have a less than. So less than simply means that we are going to be using a dashed line. So I'm going to draw my line in this form. I'm using a dashed line because it is a less than. So this is how the graph looks like. So how do we test for our solution? How do we test for solution? We have to test either above or below. Above or below. Region above the dotted lines represents above. Regions below the dotted lines represents below. So I could decide to choose any point. I want to choose 0 here. I want to choose 0. So for testing, let us test at 0, comma 0. That means x and y, they are represented by 0. I'm going back to my equation. If I put y to be 0 here, x 0 here automatically means 4 times 0 plus 2. So that means 0 is less than 2. That is true in this case. 0 truly is less than 2. So without testing on this other side, we can see that we have our solution below. But for confirmation, let's just pick a point. Let's assume we pick a point here above the line when x is minus 1, y is 1. Above the line when x is minus 1, y is 1. So let's carry out the test and see. So to carry out the test, let's see the test when x is minus 1, y is 1. So y 1 less than x is minus 1. 4 times minus 1 is minus 4 plus 2. 1 is less than minus 4 plus 2 is minus 2. 1 is less than minus 2. That is not true. So that means any point above the graph that you pick will not satisfy this condition. Alternatively, it means any point I pick that is below this linear graph, this inequality graph, below it will satisfy this condition. Inversely, it means that testing for up is not the right thing to do. So I'm going to do my graph this way. What does it mean? It simply means that down the graph is where I have my region of solution. So my region of solution is down the graph. Every point here will satisfy the inequality. That is, for this example, in our next video we shall take another example and then we see how it works. Thank you for watching. See you next time.